started again. Hello everyone. Okay, good morning everyone. So is it clear now? A bit problem was there. Good morning everyone. Sir, today this is the first class. How are you? Good. How are you all? Doing good? Sajid, Ruchi, Anwar, Rutvika, C, Akash, Sahitya, Roshnavi, Rutvika, Ram. Okay, no problem. So we'll continue with the topic. We were studying periodic table in the last class, I think, and we were dealing with that size part. Okay, na? So nice. You all will become doctor one day if you will study. Okay, na? So if is always there. Okay. So let's see one point now. In the last class, I think we revised that cation, anion, and all. Okay, na? So just let's do a recap and we will start. Okay, na? Already we are a bit late. Call your friends quickly. Okay. So you just tell me which one is bigger, cation or parent atom? Which one is bigger, cation or parent atom? Which one is bigger, cation or parent atom? Everyone write the answers quickly. You can write in shortcut also. If you write PA, I will understand it. Okay. Anion or parent atom? Now question changed. Anion or parent atom? Anion or parent atom? Anion, correct. What is the rule for isoelectronic species? Size is what? Size is inversely proportional to. For isoelectronic species, size is inversely proportional to. Size is inversely proportional to atomic number. So these were the things which we studied in last class. I gave you a list of S block elements also to compare. Think of lithium or iodine, which one is bigger? Lithium and iodine, which one is bigger? Lithium, Anwar. So this was the problem only, so we edited it. Shinu, Joshna, Bharat, Gopi, ठीक है, निहारिका, सरस्वती, भव्या, understood? ठीक है? So let's see this part now. So in the last class, I think we have written till S block that point. ठीक है ना? So you can put the next point there now. The radius part is completed. Covalent radius, van der Waals radius, metallic radius, ionic radius, all the things we have studied. So you can put a next point and you can write something. Factors affecting the radius, we have studied that also. Okay. So now you can put some point like next point you can write radius of isotopes. Radius of isotopes exactly same. Okay, na? So this is a very important point which we should keep in mind. Generally, it is not asked. Very rare questions are there. One previous year question is there. That's why we are studying it. So chlorine is there. So chlorine, suppose we are having two isotopes, chlorine 35 and chlorine 37. And if anyone asks you to compare the size, then what you will say? Ki both are same. Achha, we have written that part ki size is directly proportional to negative charge, inversely proportional to positive charge. We have written all these things. Just remind once. Written na? Okay. Chalo, theek hai, fine. So this is the next point which you have to copy. And okay. So about the isotopes. Now again we are going to write something about this thing. Smallest. If I ask you smallest atom, what you will say? The smallest atom. So we will say hydrogen. If I will ask you largest atom, ठीक है ना, largest atom, then you can say cesium. We are not considering a seventh period element. ठीक है ना, we are not considering seventh period element. Like, so largest cation, if they ask you smallest cation, then what you can say? Smallest cation. So H is the smallest atom. You make a cation, you will get the smallest cation. Clear with this point? Then if they ask you smallest anion, what you can say? Smallest anion, F minus. Now there is a very important and very twisting thing, mind blowing. ठीक है ना, कि if they ask you largest anion, then what you will say? We say H minus. We say H minus. Now, why we are giving you this data? Because if any question, suppose we are comparing the size and H minus comes there, then you have to think the size of X minus is quite high. ठीक ना, very high. ठीक है ना? And why they say like this? They say like this here, because here we are having one proton and we are having two electrons. So don't think like this, कि sir only two electrons are there. Don't think like this, कि sir only two electrons are there. Electronic repulsion will be there. ठीक है, fine. Only two electrons. Rest are having 17, 80 electrons. ठीक है ना? But what you have to think? You have to think here like this, कि proton is one, electron is double. Don't see two. Say double. Electrons are double. ठीक है ना? Getting the point? Electrons are double than protons. Now this thing you will never find in any of the elements. ठीक है ना, कि electrons are double of the proton. So proton will try to attract, but electrons are double, so repulsion is very high. So the size is big. Clear with this point? So these few data are there, and here we have ignored. Here we have ignored seventh period and astatine element 80. 80 everyone knows. So these things we have. Is the voice clear? Video is lagging or what? Okay, chalo, theek hai, fine. So these things you have to copy. Now let's do few questions and then we will write the final exceptional things. Let's do some questions and then we will write the exceptional thing. So what kind of question they can ask you? ठीक है ना? So let's see this question first. See, don't worry, just concepts are there. Like suppose I am giving you four elements: boron, carbon, nitrogen, oxygen, and they have given you the size. This size are not related to the original. I am giving you some random data only. Suppose size is given ki 80 and 100, and suppose you are having 70 and 75. Now you have to match column 1 and 2. You have to match column 1 and 2. How you will do this question? How you will do this question? Now few people may think, "Arey sir, I don't remember the radius. How I can do this?" ठीक है ना? No one can remember all the radius. Very difficult thing. So you have to just see relative part. Now see, we have written these elements in a period. Can you see this point? We have written this element in a period. ठीक है ना? Left to right. ठीक है ना? What happens? As you are moving in a period, size will decrease. Who is biggest? Boron is biggest. And who is the smallest? Oxygen is smallest. So just match it. Boron is biggest, so give 100 to him. ठीक है? Oxygen is smallest, so give 70 to him. So just a relative order we are keeping. Not exact we have to remember. ठीक है ना? So it is 100. Now this is second largest, so 80. This is third largest, so 75. Oxygen is smallest. Like this we have to try the question. One more question they can ask you like this. See, if size of Cl atom is any random data, whichever is your favorite number. ठीक है ना? So suppose I am writing 112 picometer. ठीक है ना? Although means ठीक है, not correct or exact data we are writing. this. So now what they will say, ki find, what you have to find the radius of CL plus CL minus respectively. ठीक है ना? And your options are like this कि one value is 112 only, the other value is your CL plus and CL minus we are saying na. So the first option is 112 112. The next option is suppose I am writing here 90 90. The third option is like this कि 120 and 110, or you can write here anything like 95. And the fourth option is like this कि fourth option is having this one 95 and this one is suppose 120. ठीक है? Now can you tell the answer of this? Rest people are still missing. I think due to this technical problem they have not joined. ठीक है ना? So if you are in contact you can tell them. Clear? Okay, so what do you think, which is the correct answer? Fourth one, see, you have to see like this, you have chlorine and they are asking cation and anion. So cation is smaller than chlorine and anion is chalo theek hai, sorry. So what we are saying ki we are having cation and anion. Cation is smaller and anion is bigger. So I have to write cation first, so it should be a smaller value, and I have to write anion than this. Clear? Okay. Now come to the next part. So again we are having one question like this. So we are practicing some questions based on radius. What is the next question? Ki if given data is like this, ki if given size of K plus is almost equal to size of F minus and it is equal to suppose 1.85, like this they have given 1.85, then find size of K and F, and your options are like this. The option is 2.1 2.1 1.6 1.6 1.6 2.1 2.1 1.6. Now check this question and try to give the answer. What do you think? No, ionization energy is not in the syllabus. We have the syllabus till radius only. Okay? We have the syllabus till radius only. Okay. Tell your friends, I think many are missing the lecture. Okay? What you are saying, 3 or 4? So many people are confused. Some are saying 3, some are saying 4. Sindhu is saying 3, Devendra is saying 4, Vijay is saying 3rd, Srinu is saying 4. So how to do it? Sanjana is saying 4, Joshna is saying 4, many are saying 4, but many are saying 3 also. Okay, so be patient. ठीक है ना? See what you have to do. First thing, what they are saying कि K plus is 1.85. You have to find K. Now you tell K is bigger or smaller. K is bigger than K plus or smaller than K plus. So we know it is bigger. That means K value should be more than 1.85. K value should be more than 1.85. And you are having CL and CL, you are having F minus and F. Now who one is bigger? F minus is bigger. Take it up. So F minus is bigger. That means what? F is small. So the value should be less than 1.85. Is this clear? So K value is more than 1.85 and F value is less than 1.85. So we have only one option. K value more than 1.85, F value less than 1.85. Clear with this point? So see, what we come to know from all these points, कि भाई question practice is very important. If you know the concepts also, then we should know how to apply it. Now many are knowing. I asked you previously Only what? Ki cation parent atom, anion parent atom. You said the correct answers. But now we have to apply these concepts. Okay, na? So how to apply it? So that's why we say ki before going in any exam, you have to practice many questions, 50 to 100 questions, practice, then go and give the paper. Okay, clear? Okay, no problem. If wrong, we'll do it correct in the exam. Okay, done? So these are few questions. Okay, na? Then let's study something, or you can do one more question also. Let's see this part. You remember van der Waals radius? We were saying. So van der Waals radius can be calculated for non-metals also, and it can be calculated for noble gases also. Generally, in noble gas, we calculate van der Waals radius. Okay, na? So van der Waals radius can be calculated in bonded form also and non-bonded form also. Then I told you which bond is preferred for calculating the covalent radius, single bond, double bond, or triple bond. Do you remember this? Which bond is, now people are joining slowly and gradually. You got the notification, so they say na ki subscribe, like, share, and what? Click on the bell icon. So you should do all these things. Okay. Okay. So we have said ki to calculate covalent bond, we should consider single bond. Okay, na? Not double, triple. Because in double, triple, overlapping will be more. So the data will not be correct. Okay? Only single bond. And homoatom, we have also used one word. Do you remember homoatom? So we can write one question like this, ki which compound is preferred to calculate radius of carbon atom? Radius of carbon atom. And your options are like this: methane. Second option is ethane. Third option is ethene. And fourth option is your ethine. So what do you think? For covalent radius, we want single bond. 1 point. Second point, you are forgetting the second point. Homo atoms connected, same atoms connected. There should not be electronegativity difference. Getting the point? So both points are compulsory. So today they have played prank with you. Huh? Link something else, live class somewhere else. Okay? So see, in methane you have a single bond, but it is CH bond, not a homoatom, heteroatom. In ethane you have CC single bond. In ethene you have CC double bond. In ethine you have CC triple bond. So I will prefer ethane. Getting the point? Okay, done. So these were few questions which we should see. Okay, now come to the final part. That is your exceptional cases in radius. Okay? Exceptional cases in radius. Okay? And at last, after completing this class also, we'll revise a few things regarding prediction of element and all. I have told you two methods. One was normal conceptual method and one is your shortcut, means jugaad wala method. Okay, na? Okay. So let's see this. What are the exceptional points? Do you remember something? So first point is we will talk about group 13. Which elements are there in group 13? Boron, aluminium, gallium, indium, thallium. Correct? Now what? Everyone knows down the group, size increases. So you will say, sir, boron, then aluminium, then gallium, then indium, then thallium. Size is increasing. But what is the problem? Do you remember? So we'll discuss that jugaad method only. Okay, na? Ki how we can tell. Aluminium and gallium problem. They are saying कि भाई exchange it. Gallium is smaller than aluminium. Gallium is smaller than aluminium. Now, how we can explain this? Getting the point? ठीक है? Still 10-15 students missing. ठीक है? Tell your friends. They are waiting somewhere else for the class. ठीक है ना? Okay. So all India 10th in what? Deleting the message. Okay. So see, now what we have to do? See, before aluminium, there is no D block element. D block starts from here, fourth period. So we are having 10 electrons. We are having what? 10 electrons in 3D. Now what was happening? See here everyone, I put one electron, one proton, one electron, one proton, one electron, one proton, one electron, one proton. So proton was increasing, nuclear charge was increasing. But what happened? These electrons are kept in 3D. 3D has where poor shielding, screening, poor shielding. So due to poor shielding of 3D, Z effective increases and finally it starts attracting the electrons of gallium and size of gallium is reduced. Getting? Before gallium, 10 electrons in 3D is filled and 3D has very poor shielding. So Z effective increases and size is decreased. So what you will write the reason? Due to poor shielding or good shielding? Due to poor shielding. Whose poor shielding? Poor shielding of 10 electrons in 3D. Due to this, what will happen? Z effective will increase. That means what? Size will decrease. Got the point? Okay. Similarly, we can say here also. See, here we are putting 3D. Here I will put 4D. Here I will put 5D. So I'll put 5D also. And you will put 4F also. See? So here the more shielding, poor shielding. So what happens now? Thallium should be this much. See? Thallium should be this much big. But due to poor shielding of 5D and 4F, its size is decreasing. Now it is only this much. Still it is better than this. You can see like this. Suppose this is your 112. This value is like 117. This is not exact value, but the data is like this. Gap is very less. Gap is very less. So they can ask you one more question here. Why thallium is smaller than expected value? What you will tell? Two questions we will do here. If I will ask you one question, why thallium is smaller than expected value? What you will say? Again, same logic, sir, due to poor shielding of 4F and 5D. So its size decreases. Still, it is a bit bigger than indium, but size is less. Okay, na? So what you will say? Due to poor shielding of 4F, 5D electrons. Clear with this point? Done. One more question we will add here. What one more question we will add? Listen carefully. Suppose you are having aluminium, gallium, indium, thallium, and we are talking about size difference. His difference is X, here difference is Y, and here difference is suppose Z. Question is like this, which has minimum difference in size? What you will say? Aluminium, gallium means X, Y or Z. Which is having minimum difference in size? What you will say? X or Z? बोलो minimum difference in size. अच्छा, you can skip a bit. Aluminium, gallium is there ना. चलो इसको हटा देते हैं. Because here's gallium, indium. Let's talk about YZ only. Suppose if I talk about YZ only, then what you will say? So we are going like this. Ki here what happened? Here also contraction was there. So the size is less in case of Z, you can say. ठीक है ना? So it is like this कि Y gap is more as compared to Z. So lower elements have less gap. Lower elements have less gap. ठीक है ना? Keep this in mind. ठीक है ना? Lower elements in a group has less difference in size. Clear? So one exceptional part done. Similarly, they can generalize it for group 14 also. They can generalize it for group 14 also. They will ask you why size of tin and lead is almost similar. See, again what will happen? Here there will be what? Contraction. ठीक है ना? So tin and lead will become almost similar. Got the point? Everyone see it? ठीक है? All have written Z. Nice. Very nice. ठीक है? Good. Very good. Okay. Now let's come to the next point. So second point, we are talking about 3D series. Do you know this point? Which are the elements in 3D series? Scandium, titanium, Sachin Tendulkar, very crazy man. Science teacher, very cruel man. Feko nahi, copper, zinc. Feko nahi, copper, zinc. Okay. So what we should know? Array, this is 3D series. As you move in a series, as you move in a period, size decreases. So scandium should be bigger than less. But what is happening? From iron, you will see the size is almost same. And moreover, here the size increasing. Compare the size of copper and zinc. Keep in mind, they will ask you. Yes, correct, Nitisha. 3D series or fourth period? Anwar, correct. ठीक है ना? So copper, zinc, keep in mind. They will ask you who is big? Zinc. Now, how to explain these things? We will explain these things on 2 points. What are those 2 points? See, A point and B point. You know one thing. What you know, batao? How size increases? ठीक है ना? How size increases? You can say, sir, electronic repulsion. More electronic repulsion, size increases. Am I correct? जल्दी से देखो. Electronic repulsion. As electronic repulsion increases, size increases. Am I correct? ठीक है ना? So 2 points are there कि as electronic repulsion increases, that implies size increases. Clear now? And how we will decrease the size? You will say कि if Z effective is more, that means size will decrease. Are you getting these 2 points? Are you getting these 2 points? ठीक है? Everyone see it quickly. ठीक है? So for decreasing the size, increase Z effective. And for increasing the size, what you have to do? Repulsion. What you have to do? Repulsion. ठीक है? Now we will explain this. How we will explain? Where size is increasing, you say repulsion is dominant. Where size is decreasing, you say Z effective is dominant. If nothing is happening, you say both are same, cancelling each other. So now you tell me in this point, everyone see here, you tell me in this point, how we can explain this? A is more or B is more? Size is decreasing, A is more or B is more? Everyone. What you will say? Size is decreasing. That means Z effective is the dominating factor. See? Okay, gaming bro. Okay, now we will talk about here. Here what is happening? Here size is increasing. Size is increasing means what you will say? Repulsion or Z effective? Here you will say, sir, B is dominant. Repulsive forces are dominant. So size is increasing. Clear? Come to this point. Here size is same, almost similar. What you will say, sir? Both are similar. They are cancelling each other. ठीक है ना? So in fact, this explanation is after the answer. ठीक है ना? Once we were knowing the answer, now we are trying to explain it. Is it clear? ठीक है? All of you got the point? So zinc and copper, remember this point. फेको नहीं, size is almost similar. ठीक है? Now come to the third point. Okay. What is the third point? Third point is your lanthanoid contraction. Now the question is, what is this lanthanoid contraction? Listen carefully. Okay. So now we remember many elements and their atomic number. Okay, we have remembered many elements and their atomic number. So see, we are talking here, suppose you have 3D series. Everyone see, and you are having 4D series, and you are having 5D series. So what do you think? As we are moving down the group, size should increase or decrease? Yes or no? Increase or decrease? As we are moving down the group, size should increase. So this should be the order. Ki fourth period, fifth period, sixth period. Sixth period biggest. Then what? Fifth period. Then what? Fourth period. But what is actual thing? It is like this. Ki as you move from 3D to 4D, size increases. But in case of 4D and 5D, size is almost same. 4D and 5D series element size is almost same. Clear with this point? Okay? Got the point? Okay? So how we can explain this? This is explained on the basis of lanthanoid contraction. So they will give you example. Do you remember fourth group? Which elements are present in fourth group? Titanium, zirconium, hafnium. You know the atomic numbers? Yes, 22. This one is your 40. This one is your 72. So they will say like this, ki zirconium is bigger than titanium. But zirconium and hafnium size is almost same. Clear with the point? Okay, na? Similarly, next, all the elements of 4D series and 5D series have similar size. So zirconium, hafnium, niobium, tantalum, molybdenum, tungsten, technetium, rhenium, and so on, rhodium, iridium, Ag, Au. I am writing few important. Palladium, platinum, all are having similar size. Now what? Everyone remembers this. Nothing is new. Everyone knows. And they will ask you most of the question in zirconium and hafnium. They will say like this, why zirconium and hafnium is having same size? You have to say lanthanoid contraction. Okay, na? They will say which of the following is having same size, and one of the option will be zirconium and hafnium. Okay? But you have to see other elements also, niobium, tantalum, and say these elements once. Say these elements once. Okay, na? So what will happen? Ki you will be familiar with the word. Otherwise, you are not remembering only ki what is NB. So niobium, tantalum, molybdenum, tungsten, rhodium, iridium, Ag, Au, rhenium, technetium, Pd, platinum. Clear with this point? Got the logic? ठीक है? Okay. अब आ जाओ इधर. अब क्या करने का अपने को? अच्छा, now what? Everyone knows this. Then they will ask to now see 90% students are trapped in this question. What question, sir? This question. What this question? You remember third group. Which elements are present in third group? Jaldi batao. Bhavya, tell the number elements present in third group. इधर बताओ मेरे को जल्दी. त्वरगा चपंडे. What do you have to say? Third group. Scandium. And what is their third group? Scandium. After scandium, yttrium. After yttrium, lanthanum. Do you know the atomic number? Yes sir, 21. This one is 39. This one is 57. If they ask you same thing, कि this is 3D, this is 4D, this is 5D, who is bigger or what is the order? What you will say? Is this true? Is this point true? Ki yttrium is almost similar to lanthanum. Everyone say it. Is this point true? Yttrium is almost similar to lanthanum. Very good. Correct. Correct. You have said. ठीक है ना? Sindhu, Bhavya, Gopi. Many are saying no, 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 no. Okay, so this is the twist. ठीक है ना? Here we don't have to get trapped. ठीक है? So what will happen? Ki this see, this lanthanoid contraction thing starts from after lanthanum. It starts after lanthanum. Lanthanum tarvata, not from lanthanum. Here to no problem. Shell increasing, they are very happy. Suppose a scandium is having 4 cells, very happy. Yttrium is having 5, very happy. Lanthanum is having 6, very good. Problem starts after lanthanum. Now the question is, what happened between lanthanum and hafnium? Between lanthanum and hafnium, what happened? So the size is decreasing. So you think like this, कि scandium was small, yttrium was bigger due to extra shell, lanthanum was bigger due to extra shell. So hafnium should be also big. But there is one problem. What is the problem? You know, see, lanthanum is 57, hafnium is 72. 14 elements missing. Where are these 14 elements? So what happened? This is 4F series from 57. Now see what happened. Listen everyone focus here. Suppose I am lanthanum. Suppose I am lanthanum. I have my extra shell. I am very happy. I am bigger than yttrium. Now what? In this confidence, 57. Now 58, I went in F block. I am gone. 58, 58, 59, 60, 61, 62, 63. And in this, what is happening? Electrons are going in F orbital. Nuclear charge increasing. But when I come back, now my extra shell benefit is gone. ठीक है ना? Due to contraction, you are putting one electron in F orbital, one new proton, one electron, one proton, one electron, one proton. But you are putting electrons in which orbital? Batao, you are putting electrons in which orbital? You are putting electrons in 4F orbital, whose shielding is very poor. 4F orbital, poor shielding. So when you will come back, ठीक है ना, 58, 59 like this. Suppose this is lanthanum, ठीक है, this is your lutetium, ठीक है ना, 71. By the time you reach till lutetium, the size has reduced. Why size has reduced? Due to poor shielding of 4F electrons. So this is only lanthanoid contraction. What we can say, बताओ, कि regular decrement in the size of 5D series elements, 5D series elements due to dash shielding. Now fill in the blanks. It's time to fill in the blank. Dash shielding of dash electrons. What you will say? Poor shielding, good shielding? Poor, chadda. Poor shielding of 4F electrons. Clear this point? ठीक है ना? ठीक है? So this is the point. So this is your lanthanoid contraction. You can understand it like this also. कि suppose two friends were there. One friend, this is the second friend. ठीक है? This friend name is Y, yttrium, and this friend name is lanthanum. ठीक है? He was having 3 chocolates. He was having 4 chocolates. ठीक ना, क्या टॉफी लिख दें? Let's write toffee. Toffee. ठीक है, चलो ठीक है. So he was having 3 chocolate, he was having 4 chocolate. Both have to reach this target. ठीक है, without eating. So this person reached here, he was still having 3, but this person slowly he was eating the 4th one. This person slowly he was eating the 4th one. So when he reached here, now he is not having 4 chocolates, 1 chocolate in his stomach. Now he is having only 3. So both are same. This is zirconium, this is your hafnium. The extra benefit is gone. Clear with this point? So this is your lanthanoid contraction. ठीक है? Okay, done. Now we will make a graph to understand this point easily. You will find this graph in D block NCERT. So you will study there also. We are making it here also. See, what is the graph? The graph is like this. ठीक है ना? So this is your size. This is your atomic number. This I am making for 3D series. See, this part is nickel. After nickel, there is a bit increment. This is which series? 3D series. Okay. Now you see here. Who is bigger than 3D series? Jaldi batao. Who is bigger than 3D series? 4D series. ठीक है? But when you will see 4D and 5D, when you will see 4D and 5D, their size is almost same. This is your 5D series. ठीक है ना? So this graph is made in D block NCERT. ठीक है? So is this point clear to everyone? कि as we move from 3D to 4D, size increases, but from 4D to 5D, size is almost constant due to lanthanoid contraction. Lanthanoid contraction what? For a poor shielding, Z effective increases, size decreases. Clear? Done? Okay. That's it. Now we will write the last point. Last point for today. Now listen carefully. Last point for today. What is this last point? Ki you will find one statement like this. Ki as we, everyone see this point. You have read this or not? Ki as we move in a period, size decreases till halogen and then increases. ठीक है ना? और somewhere this is also written कि noble gases, this is also written somewhere कि noble gases are biggest in their period. Have you heard this word? Have you heard this word? This statement? Yes. Why? Because in case of noble gases, we are measuring van der Waals radius. Van der Waals radius measured. ठीक है ना? Now what? This comparison is not good. This comparison is not good. See, I will write here. This is your beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Size is decreasing. See here, size is decreasing. But here what happened? Size increased. In rest of the cases, you were considering covalent radius. But in neon, you considered van der Waals radius. ठीक है ना? Now van der Waals radius is valid for non-metals also. So I told you na कि if you have to compare something, similar properties we have to compare. Compare his van der Waals, compare his van der Waals. But you are not doing this. You are comparing his covalent and his van der Waals, which is not a correct way. But then also this statement is running very nicely in every book and everywhere कि noble gases are bigger. If we will check everyone's van der Waal, ठीक है ना, then this may not be true. ठीक है ना, if you will check van der Waal radius of every element, normal order is followed. ठीक है, clear with this point? Compare van der Waal for all, you will get a normal order. So this is the last point which we have to see. Now we are doing just discussion part. ठीक है ना, so you practice questions. So enough for today. Some they have given you reporting date, I think na. So enough for today. Syllabus is till this point only. ठीक है ना, and ionization energy is not the part. ठीक है ना, you have to report here, I think. Now listen one point. We will discuss few things only. Like prediction of element. I have told you like this. One is conceptual method. The other one is jugaad method. What was jugaad method? It was like this. Ki anyhow you take out the atomic number. Suppose they have given you atomic number 86, very good. They have given you 90, very good. ठीक है ना? If they have not given, you add all the electrons. Now, how we were doing this? I told you that we are knowing a few atomic numbers like 18th group, 12th group, 3rd group, 4th group. These atomic numbers we are knowing, which will help us. Can you all write the atomic number of noble gases? Everyone, quickly. Can you write atomic number of noble gases? Weekend syllabus up to radius. Ionization energy is not there. So Sajid has written correctly. Sir, it is 2, 10, 18, 36, 54, 86. Now suppose anyone asks you 53. 53 which group? 53 which group? 53 which group? 17th group. Simply you can subtract. ठीक है ना? Now suppose anyone asks you 41. Anyone asks you 41. Now what? You should take help of this group. See here, everyone knows we are having zinc, cadmium, mercury and copernicium. ठीक है ना? Everyone knows कि zinc is 30. Everyone knows the magic number also. Do you know the magic number? बताओ इधर. What was the magic number for D block except 3rd group? 18, 32, 32. So this was 48. This was 80 and this was 112. So if anyone asks you 47, you will come to know. 46, you will come to know. 45, you will come to know. Like this. Okay? So at regular interval, we are knowing the atomic number and we can subtract. 81, anyone ask? 81. Got the point? So at regular interval, we are knowing the atomic numbers. We will utilize it. Do you know the atomic numbers of third group? Scandium, yttrium, lanthanum, actinium. Everyone knows the atomic number 21, 39, 57, 89. Is it clear? 4th group atomic number, titanium. What is titanium? Batao. Titanium is 22, yttrium, zirconium 40, and then we are having lanthanum. Here we are having hafnium 72. We are having rutherfordium 104. So I asked you 41. 41 where? Here. You will simply say, sir, 5th group. Clear? So at regular interval, we are knowing the atomic number. You just subtract, add. Clear? So hope this will help. So enough for today. If you want to take, this is the QR code. कहाँ गया QR code? Share. ठीक है? So any other doubt? Okay. So thanks everyone. Bye for today. Revise. I am telling you again and again, before sitting in the paper, you have to solve questions. Don't only read the notes. Solve questions also. Anywhere, from anywhere you can solve questions. Okay? So hope you give the test nicely. This is the QR code. Okay? Bye-bye. Bye, Shranya, Sahiti, Keshav, QR code, Durga, Sajid. Okay? So from next class, we will start ionization energy. Okay? Umar Ali, Arey, come back. You have classes now. ठीक है? So hope you understood. So thanks everyone. Bye bye. Take care.